This is the next one, 7th. Minus a square, ab, ac, ba. This is b square and this is c square. Okay, let's make that correction over here. This is b square and this is c square with a minus, obviously. This is a square over here, right? Let's make that correction. Let's not make that mistake. This is minus. Okay, this is minus c square minus b square over there, and this is 4a square, b square, c square. Okay, and how do we prove this one? Let's see. Let's see. In the LHS, what do you have? In the LHS, the determinant that we have, let me rewrite it so these corrections are clearly visible. We have minus a square, ba, ca. Oh, there are plenty of a's over here. Then you have ab minus b square, cb over here. Yes. Then you have ac, bc and minus c square. So there are plenty of a's, there are plenty of b's and there are plenty of c's in this, as you can observe. Yes, that's what we have. Okay, so what are we supposed to do over here? Do you observe that we can take out a common from here. We can take out a b common from here and we can take out a c common from here. What you'll have is, on the LHS you'll have ABC in the left hand side. You'll have, so in the LHS you have ABC outside the determinant and what remains is minus a, b, c. Okay. Then you have taken out b common, this will be a minus b and you'll have c over here. From here you have taken out a c, what will remain is a, b minus c. Yes. What next? So for the next one you can observe that all of these terms contain a, all of these terms contain b, all of these terms contain c. So from the first row you can take out a common, from the second row you can take out a b common, and from the third row you can take out a c common. Yes, we are moving in that direction of a square, b square, c square. Yes, let's do that. Taking out common a, this will become a square, b square, c square, and what will remain is minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. This is what will remain. What next? We are supposed to find the value of this. Yes, we are supposed to find the value of this. But once again using properties. Let's go ahead. This gives me LHS is okay. A square, B square, C square is okay. And do we observe that there's a minus 1, there's a 1 and 1. So I can replace R1 by R1 plus R2 plus R3 to give me something. What will that be? Please observe. Minus 1 plus 1 will become 0, there will be a 1. 1 minus 1 will become 0, there is a 1. 1 plus 1 minus 1 will be again a 1. So in the first row you will have 1, 1 and 1 remaining. Okay. But that will be extra 1. Let's try to create some zeros. We haven't created any zeros yet. So if you want to create any zeros, what we can do is alternatively, I have another idea that I can share, and we can create some zeros over here. By not adding R3 along with this, let's add R1 and R2 only. Let's add R1 and R2 only, and what will remain is this. Minus 1 plus 1 is 0, 1 minus 1 is 0, there are zeros. 1 plus 1 is 2, okay, that's a problem, but never mind. The remaining things, what else? What about the remaining things? Can you please observe that you'll have 1 minus 1, 1 and 1, 1 minus 1 remaining over here. Right. If you want, you can expand very easily along this row over here. But before that, can we create more zeros? Yes, we can create some more zeros. Let's replace R2 by R2 plus R3. And what we'll have is a square, b square, c square, 0, 0, 2. This will become 2, 0, 0 and 1, 1 minus 1. This is what remains. Right? And now you can easily find this value, a square, b square, c square. The value of this determinant will be equal to what? The value of this determinant will be 2 times this. 2 into 1 minus 1 into 0, which is 2 times 2, which is equal to 4 times a square, b square, c square, and yes, this is my RHS over here. This is what we wanted to prove. Hence, proved. Right, that's the complete solution of this question, as you can see behind me. Is that all? Yes, that's all in this question.